Hey everyone, this is Dan, and today we're going to take a look at the topic of instance trails. And what I mean by that is, for example, we have a rotating sphere here with some noise, and we can define a number of trailing instances and also the time span that they cover. And we can change this dynamically. We can change the distribution of these and also other fun stuff like reversing the order. And this makes it very cool to cross into other shapes. As you can see here, I just crossed into a random noise instancing. I'm not the only one who covers this topic, but my approach is different because in my approach you can mess with the trail length and stuff like that. But you can check out exsstas's tutorial how he deals with instance trails using feedback to cache basically the trailing information. But the main difference there is that the trail length, the time span, is defined by the texture size. And for example, if I want to change the trail length, I have to change the number of trailing instances actually. So I cannot have 10 trailing instances that cover a span of 5 seconds or however many seconds. I'm tied to the trail length defining the time span also. So that has some drawbacks, but also this technique of using feedback to store the information has some other cool opportunities, so be sure to check it out, to check out his tutorial. And also Alpha Moonbase covers this topic in his Noodle Salad component that is available on the TDO lib. Here you can see that we have actual lines, trailing lines. He's also using feedback, by the way, so if I wanted to change the number of, the length of these trails, I have to change it, and then I cannot, it's not really dynamic to change the length of them. But it's a very cool approach. Also really nice how these lines are calculated. Basically no vertex shader is used here. I have a Patreon exclusive version which uses a vertex shader to draw the lines, and it's also inspired by exsstas's video on this topic, but I had to modify it quite a lot. And there might be a part 2 of this video covering other techniques using these instance trails. So today we're gonna build this example, and it's gonna leave us with a component that we can reuse in other projects, and also we can very easily transform our already existing instancing, top instancing networks to trailing ones. And let's get to it. Except if you just want to use it, then join my Patreon, because the project file is going to be there with doxes. So consider doing that. There's a lot of things there. I don't think you will regret it. Alright, so let's start with a clean slate and build our instancing network first. I'm going to start with the noise data and make this non-monochrome, 32-bit float, nearest pixel. And let's expose the resolution as a custom parameter, and let's make it maybe 20 by 20. Let's put a null down. With Alt-N I can put a null very easily and call this null instance transform. And let's put down a sphere that we're gonna instance. Let's make it smaller, and a geo, a camera, and then a render, like so. Enable instancing and use this as the translate OP RGB. Cool. Let's also have a light. Nice. Now we can make this smooth if you type ExprTime.seconds, but I don't like typing ExprTime.seconds, so that's why I made a component, which you can find a video about somewhere, description somewhere, I don't know. So I just type hashtag 80 times 0.2, and these are moving now. Let's move them to the 0 position, and let's just increase the period, and maybe actually just have 10 by 10 and even slower. Alright, great. The gist of the trailing technique is going to rely on a cache stop and many cache selects. So let's start building that part. I'm going to put down a cache. And a very important parameter of this cache is going to be the cache size, basically the maximum number of frames that we store inside this cache and that we can choose from. And I'm also gonna start building a component around this and call this instance trailer. So we should expose this cache size. This is going to be important. This is going to be our maximum trail length. And I'm going to make this maximum 300, let's say. And then we need a cache select, or rather many cache selects. Let's start with 2 maybe. Like so. And this is going to be cache index 0, so it's going to be the same. And let's make this minus 60. So it's going to be now, because I'm on 60 FPS, it's going to be minus 1 seconds. And how I can easily get them into one texture is with a layout top. If I connect both, set it to scale resolution on. So we started with 10 by 10, now it's 20 by 10. That's cool, and let's output this. We can also set all of these to nearest pixel. I like doing that. And now if we update this, now we have double the amount of instances and they are following each other. Maybe it's hard to see. Maybe let's reduce this to just 1. And we can see that this is following the other one. And what we need to do now is replicate a bunch of these cache selects to have many trails follow one instance. And this is also very differs from the previous approaches where they were using feedback to cache the instance data. Here we are using an actual cache stop and lots of cache selects, and we can define the cache indices as we want, which we will do later. So that's why we can shrink and expand the time span and also have different distribution of the trails and so on. Now it's time to replicate a bunch of these. So let's put down a replicator, and we need a pattern to define, well, the number of the cache selects and also the distribution of the cache indices. So let's put down a pattern. We need a ramp, and we need a length, which we're gonna expose here. I'm gonna name the cache size to cache size max, and the length, let's say depth, and let's make it maximum 300, default 10. Let's start with 10 and put down a math after this. So we're gonna define the cache indices here with this pattern. I'm gonna again customize my parent component, and we're gonna use the rearrange. And let's add a new parameter that's called cache span. I'm gonna reorder these. And our cache span, let's say it can go to 300, default 10. And from range 0 to 1 to range 0 to this parent.par.cache span. Great. Now we can use this later on for defining the cache selects indices. And now it's time to do with our replicator. So let's have a master operator as this cache select. Operator prefix, let's call this also cache select. Replication method by number of replicants, parent.par.depth. Okay, let's lay them out vertically and rearrange some stuff here, like so. And in our master cache select, let's put down, I'm just going to rename this null cache, and let's write our expression here, which will fill the cache select for each of the replicants. So it will be minus op null cache channel 0, and the sample will be equal to me.digits -1. So let's recreate these, and now we see that each of them have a different cache index, which is defined by this pattern. And let's see what else we need to do. We of course need to connect them to the layout one. We can do that in the replicator callbacks. So on new op, c dot output connectors 0 dot connect op layout 1. I hope this will work. And it works. So again, this is what we need to write in this. This is gonna take the first output connector, well, it has only one, and then connect it to OP layout for each new replicant. And let's double check what we have. So we have 10 replicants. So it means that from our 1 pixel we should have 10, but we have 8 by 1. And that's because we forgot to increase the max columns in the layout. So we can just bump this to a higher number. And now we have the correct size. And let's look outside and let's see if this works. And it works pretty well. Let's actually increase this to 300, the max cache size, so we can have longer trails. And they seem to be chugging along. Let's now increase this to 5 by 5. And it's very busy, but it works. Let's also change the depth to just 3, maybe. Nice. So this is the basic component that we can already reuse in other projects, but we're gonna boost it with some more features. But before doing that, let's improve our visual a little bit. As we saw in the example, the trails were actually decreasing by size. So let's increase this again back to 10. And the way we can scale them following each other is by putting down a ramp top. Let's set this to horizontal, that's fine. And then the resolution should be, on the X, it should be, let's see what we have as parameters. We have the resolution. Let's now also add the depth here. So it would be parent.par.resolution 1 times parent.par.depth. Is it 50? Yes. 50 by parent.par.resolution 2. So now we should have 50 by 15. This is also 50 by 15. And let's put down a null IC, and use this as our scale OP, RGB. Also change this to 32-bit float. And now, as I can see, it's the other way around. So let's flip this. And now the trailing instances get smaller. We can actually add color to them also, and we can use another instance trailer. Let's copy paste this and use another noise. And let's change some of these parameters here. When did it go 5 by 15? I don't know, but let's make it 10 by 10. Okay, so I'm gonna change the parameters on this noise a little bit. And get the output of this instance trailer. And I think I made a mistake. This should be IS as in instance scale. And this will be null IC. Use this as the color OP, RGB. And now we can have changing colors, and we can also define the change, the time span of the change over the instances. So now with 0, all of them are the same color. And if I start to increase this cache span, the colors run through. We can also make this a little bit faster so we can see the change more. I hope it's visible. Like so. Actually, let's decrease the number of these because it's getting a little bit busy. Also, we can make them a little bit more spread out. Okay, so just for demonstrational purposes, we can do a similar thing for the scale to involve the instance trailer once again. So I'm gonna copy paste that, put down a ramp, and have the same resolution there. Make this 32-bit float, maybe mirror, and let's also animate this, maybe 0.5. Also nearest pixel, and put this through the instance trailer and use it as our instancing data. And we can see that this pattern now goes through all of the trails, and we can define the span also. So we can use the instance trailer basically for every instancing parameter that we have. And we can also combine them in interesting ways. And I'm exploring this. I've explored some things, and there will be for sure more things on my Patreon for preview, but also probably more videos on this topic, how we can utilize the instance trailer. But now let's treat it with a little bit more love. The main thing that can be improved is, of course, how we define the distribution of our cache selects. We can put down a function chop and set it to input on the exponent. And of course, this should be before the rearrange, because the function works very nicely, very predictably between 0 and 1. And to swap these operators, I have a thing on my Patreon, a component on my Patreon, which adds a hotkey that lets you easily swap operators instead of having to disconnect them and then reconnect and all that. But now with this function, we can change the distribution of them. We can move them closer or farther, like so. So this is nice, I think. And then what we also had in the example was changing the direction so that the smaller ones follow the bigger ones, and this changing of directions. So basically flipping this pattern, basically like this, can be useful in situations. And I want this to be a slider, so to go from this state to this state smoothly. And for that we need some expression magic. I'm gonna put this after the function, and also add a parameter to the parent, call this direction. And we will have to play with the range, so we need a smooth transition between this state and this state using that parameter. And the expression looks like this. I'm not gonna break it down, it took me a bit to figure it out. So parent.par.direction if parent.par.direction is greater or equal than 0, else 0. So here it is in full. And the other side is going to be pretty similar, except this is going to be minus. And of course, this cannot be greater or equal. This should be less than 0. And now, if we change the direction smoothly, what did I do wrong? I know, I think. Of course, yes. This needs to go, yeah, I wanted this to go from -1 to 1. Yeah, sorry about that. So let's change the range of the slider, -1 to 1. And now if you look at this, it should be like a seesaw, or similar to a seesaw. And if you also look at our visual, these are now changing direction. And finally, for some quality of life, we can add a little script so that when we change the max cache size, that the range of this slider also follows that. So it would be now max 191. So let's put down a parameter execute OPs. Let's look at the parent, and we're looking at cache size. I cannot type. Value change, and on value change, let's change the parent.par.cache span. I believe the name was cache span, yeah. cache span dot norm max to that value. I hope, okay, it's norm max with a capital, probably. So now we change this to 226, and now this is also maximum 226. Nice. The only drawback is now we cannot drag this slider, but I think that's fine. So now this component can be used in any instancing situation. And as we saw before, we can use it not only for the position, but also for color or the scale or rotation. There's many usages of this. As I said, keep tuned, so subscribe and join my Patreon. There will be more things around this concept. And I think what's left now is to recreate what we had in the intro. So we had a rotating sphere that had trails, and of course we will need a sphere, but because the instance trailer works with tops, we need to convert this to a top. And again, exsstas has an excellent method for that, which is quicker than chop. So I have it saved in my palette as sop render top. I will also link a video of this, and I think you can also grab this from his GitHub. So now we have the sop directly into the top. And if we want to cross between this sphere, which has now 27 by 27 points, and our noise, we need to have them have the same number of points. So now we just need to change the number of rows and columns here, and that's going to be the same as this resolution, actually. Resolution 1, resolution 2. And now we can put a cross down. And we have this beautiful sphere. I'm going to put down a point transform. Scale it down a little bit. And also, just to make it rotate, we're going to put amps time at seconds times 20. And now we see this action. Nice. And if we try to cross now, it sort of works, yeah. Except if we have a look here, this doesn't look nice, and it also causes some jumps. And that is because the sphere needs to be on the detail page, unique points per pole. And now magically, we don't have the issue anymore, which is super nice. Now everything is much smoother. The only thing left is adding a noise after this. Let's make it move hashtag AT times 0.2. Let's play with the parameters. Of course, let's look what we're doing. Look at what we're doing. Monochrome off. Offset needs to be 0. Amplitude very low, like this. And we have our sphere. We can cross between that and our noise. You can experiment crossing between other shapes. This sop render top is really great. Just a little cautionary tale, by the way. This can really mess up your system if you connect something with a lot of pixels, and also if your depth is high. So be sure to protect yourself and your patch. And I think it's smart to put down a fit top. Maybe I will not put it down because the default value of the fit top would be 1000 by 1000. So if you put down a fit top and you limit it always to something, I mean, now it's gonna make sure that if I connect a random noise to it, it's still gonna be fitted down to our defined resolution. And also on startup, things can get a bit messy sometimes. For example, sometimes the layout has everything connected twice for some reason. So the solution is just to come in and recreate all operators, but this should only happen if you copy and paste a project or something, or restart your project, and it's also only occasional. In the example, we had this as a square, and also instead of the black, it was gray. Like so. And also for the noise, I did something. Let's cross back to the noise. That I increased the amplitude quite a lot. And then I put a limit. Put it to zigzag for both minimum and maximum, so that there is an imaginary boundary now where they bounce off. We just need to adjust our camera a little bit, like so. And now they bounce off kind of at the edge. Then I put down a box, render it in with a geo. Uniform scale should be 2-ish. And then let's use a line matte. And maybe a bit more than 2. Like so. And also what I realized was that I used the same color, I mean the same texture for the color here, so I can just run this null IC. And if you want to be fancy, we can put down a function here also, RGB exponent, and I think that's more or less what we had. So that's it for this video. I hope you enjoyed this building of this little component and the flexibility that this component can bring you in cool visuals. I'm really curious what you make of this. Feel free to tag me on Instagram or just message me. And as I said, there will be more things coming centered around this component. So keep tuned, subscribe, follow me on Patreon. There's many things on there that can boost your Touch Designer workflow, for example. And yeah, thanks for watching. Ciao.